What's up, everyone? This is Dr. Jax. Today, we're going to be looking at a work energy theorem, as you see here, using a spring and a cart. What you're going to see is, as the spring gets stretched, the cart is going to be held in position, allowing us to measure the length of the spring or the change in length. Based on that change in length, we have now given the car elastic potential energy. What you'll see after that is that the person cuts the tie and the car is allowed to then move in the opposite direction. This is transferring potential energy to kinetic energy. Based on what you see here in the motion, you'll be able to calculate the elastic potential energy gained, as well as the transfer to kinetic energy and the velocity of the car. So let's take a look in full speed, and then we'll slow it down so we can measure a few different things. As you see in the corner, the cart mass is given as 502 grams, and you can see how far the spring is stretched before it is then cut and released. All right, in this next step, what we're going to use is the ruler on the screen in order to measure the change in spring length. So as the person pulls back, you can see that the spring is pulled from its rest position until where it settles here, as the car is now tied to this hook and allowed to remain at rest before it is then cut and released. All right, at this point, what we're going to do is, as the person cuts the string, we're now going to use this separate ruler to measure the change in distance as well as the time, so that we can look at the kinetic energy, especially the velocity that the car gains. Based on the two calculations that you've just done, you could then work backwards to figure out the spring constant. So let's watch. Here you can see in a super slow-mo that as the person cuts the string, the rider who is at rest begins to move down the track. Take note of the change in time as well as the distance before the person moves off of the ruler.